So I only want to see I, negative 1, or 1 when it says to simplify and you have a power of I. So anything that looks like the examples down at the bottom. In order to be able to do that, we need to talk about and find a pattern for a power of I. We should know by now that I is interchangeable with the square root of negative 1. So anytime you have a negative square root, that represents an I or vice versa. An I represents a negative under the square root. So with that being said, if we talk about something like I squared, what we're really saying is the square root of negative 1 times the square root of negative 1. If you've noticed or you figured out by now that anytime you have the same number being multiplied together, so when you're looking at something like the square root of 16, we say that that's 4 squared, or 4, but really when you're saying it's 4 squared, you're kind of saying, okay, it's root 4 by root 4, so if I have 2 of something, I get rid of the square root. So an easy way to remember I squared is, since there are 2 of them, where 2 times a half is 1, the square root symbol goes away, and I squared is the same as saying negative 1. So if you get I squared in a problem, I want you to replace it with negative 1. So if you have I squared in a problem, when you're adding, subtracting, multiplying, dividing, anything like that, replace it with negative 1. If we get I cubed, remember, exponents are the sums of 2 exponents being multiplied. I cubed is kind of like saying I times I squared, because 1 plus 2 is 3. But we just said that I squared is negative 1. So we're going to replace I squared with negative 1, or we can see that I cubed simplifies to negative I. So if you have something cubed, that's actually the same as negative I. I to the 4th, well, I could rewrite something to the 4th power as something squared times something squared. Because once again, 2 plus 2 is 4. But what did I say I squared was equal to? Well, I said I squared was equal to negative 1. So I can replace each of my I squareds with a negative 1. But negative 1 times negative 1 is 1. So if you look, I told you when we simplify, it had to be I, negative 1, or 1. Can you see how? Here's I, negative 1, negative I, positive 1. Each of these fit into one of those 4. So what about I to the 5th? How could I simplify I to the 5th? Remember, you can pick any one of these to sum up to 5. So I to the 5th can be I to the 4th times I. You could make it I cubed times I squared. But no matter what, when I simplify this, I should ultimately get the same answer. I to the 4th is 1. So you get 1 times I. Or I cubed is negative I, and I squared is negative 1. So 1 times I, or negative I times negative 1, ultimately gets me back to 1I. So, same with I to the 6th. Rewrite it using one of these 4. So we could make I to the 6th, I to the 4th, and I squared. We could make it I cubed and I cubed. You could make it I to the 5th and I. But at the end of the day, if you make it I to the 4th, you get 1. If you make it I squared, you get negative 1. So 1 times negative 1 is negative 1. And if I had done it with I cubed and I cubed is negative I cubed is negative I. Two negatives make a positive, so you'd have had I squared, but I squared is negative 1. So either pattern, either substitution ultimately gets me that I to the 6th is negative 1. How about I to the 7? Make it any substitution you want to get where you want to go. So maybe I make I to the 7, I to the 4. Why do I keep picking I to the 4? What makes I to the 4 so nice? It equals out to a positive and a positive. So it's kind of like a constant coefficient. So I have I to the 4th and I cubed. I to the 4th is 1 and I cubed is, so I to the 7 is the same as I cubed, which is negative 5.
Oh, we have to remember all these.
You have to know the first 4. What about I to the 8th? I would make it I4 because that's 1 times 1, which is 1. You notice about these 4 and these 4. They just repeated. So I to the 1 is the same as I to the 5th. I squared is the same as I to the 2nd. Or I squared is the same as I to the 6th, sorry. I cubed is the same as I to the 7. I to the 4th is the same as I to the 8th. The i's repeat on a cycle of 4. So remember I kept telling you I made all of these 4s? What that means is when you're simplifying these, you want to, in order to simplify, rewrite as a power of I that is a multiple of 4 plus its remainder. So what do I mean by that? Well, what are some of the multiples of 4? 4, 8,
16, 12,
12, 16, 20,
24, 28, 32. Keep going.
36,
40, 44, 48.
So there's this repetitive pattern of powers of 4. So I to the 13, what power of 4 is near it but less than it? Oh.
What?
13, the power of 4 near it but less than it is 12. So rewrite this as I12 and then whatever the remaining I are to get to 12. I mean to get to 13. So in this case, 1. Anytime you write a multiple of 4, it's 1. So it goes away. I to the 13 is really just I. Yes.
And this is hard as this is going to get.
For this part of it, yes. Like, beyond like a little bit of foiling tomorrow, that's it. Okay, I to the 11. What power is going to be close to this that is a multiple of 4?
8.
There you go. So it's I8, and then what's my remainder? So remember, any multiple of 4 becomes 1. I cubed has to become negative I. So I to the 11 is negative I. Okay, 91. Gotta find a power of 4 or a multiple of 4 near it. What do you think?
88.
Yeah. I to the 88. So what's 91 minus 88? 3. So once again, 88 becomes a 1. So you get I cubed, but I cubed is negative I. That's how you simplify I to powers. 244. It is what? It is a multiple of 4. Therefore, I to the 244 is really just 1. Okay, 10. So you make it I8, I squared. So you get negative 1 because I squared is negative 1. Do not fall for the trap. Just like we have variables. So if I told you x to the 6th plus x cubed, can you add those together? No, because they're not considered like terms. I's that are not the same multiple are not considered like terms. So I is not a variable. It's not. I is the square root of negative 1. However, it takes on the same properties of a variable. If you don't have another I to the same power, you can't combine them. So you simplify separately. Simplify I to the 6th. So I to the 6th we already said was negative 1. And you simplify I cubed, which we said was negative I. So I to the 6th plus I cubed is the same as negative 1 minus I. Do not write it as I cubed. Or I to the 9th. Good? Okay. Okay. So, let's introduce a little bit of new vocab. And the only thing that's changing is that up to this point in the world of mathematics, you believed that all numbers or all answers had to live in the real number system. And if it wasn't in the real number system, you got into this habit of saying no solution. Well, not quite the case. Bring on the complex numbers. The complex numbers is a system of real and imaginary numbers. So the imaginary numbers are those units of I. They exist when your calculator says they don't. So a complex number is a number that can be written in the form A plus BI. So the very, very last example we did today, that one where you have the I to the 6th plus I cubed, and we got negative 1 minus I. That was a complex number because the real part was the negative 1 and the imaginary part was the negative I. So we had a couple examples on our homework the other day where we were square rooting numbers and some of the numbers had I's and some didn't, and they were being added and subtracted together. So those were considered complex numbers. So again, here's what we believed up to this point over here on the left. What we believed was the almighty only thing in the universe in terms of numbers was we lived inside this box. Well,
you trace that really good until the last line.
Now our box has been expanded. And now we have this new part, and that's the imaginary part. So let's rewrite some numbers. Let's take what we've done. We've done lots of square roots, and we've done lots of simplifying. So let's simplify these square roots. Some have negatives, some don't. Some have I's, some don't. So I got the square root of negative 121. 121 is a perfect square. So the square root of negative 121, the minute you see the negative underneath, we produce an I. Square root of 121 is 11. So we have 11I minus 7. The stinky part about this is that it says in the form A plus BI. So typically when we write these complex numbers, we put the real part first. So in this case, the A is the negative 7, and the BI is the plus 11I. So in true A plus BI, or true complex number form, it should be negative 7 plus 11I. Number 2, 18 is not a perfect square. I see the negative, I bring it out as an I. I rewrite 18 as the multiples of a perfect and a non-perfect. So you have 9 and 2. Square root of 9 is 3. So negative 18 reduces to 3i square roots of 2. But again, that's in bi plus a form. So in a plus bi, we get 7 3i square roots of 2. $25 is a perfect square. The negative turns to an I. So you get 5i plus 7. But we like a plus bi, so we write 7 plus 5i.
You love me.
That's nothing new.
Alright,
We did this.
I know the second one.
This was on your homework 3 days ago. Last Wednesday, really. Alright, let's throw in an old vocabulary word. What's the word additive inverse mean? What is that a fancy word for? What's it a fancy word for? Additive inverse is simply a fancy word for what if I told you the definition of an additive inverse was A plus negative A equals 0. By definition, an additive inverse says that A plus negative A equals 0. It's the opposite. So I said it's just a fancy word. Additive inverse simply means the opposite. So if you had negative 7 plus 9 or minus 9i, its additive inverse is 7 plus 9i. You have negative 5i, the additive inverse is 5i. 4 minus 3i is negative 4 plus 3i. A plus bi becomes negative A minus bi. Those are the easy no-brainer ones. Do not forget what the definition of additive inverse is. Remember how I told you I acts like X? And you cannot combine unlike I's with unlike I's. If we are adding or subtracting real numbers and I's, you can only add or subtract the real numbers together. You can only add or subtract the powers of I to a 1 together. You can only add or subtract the powers of I squared together. So in 9 through 12, we're applying properties of order of operations. You're simply combining like terms. That's all we're doing here. For these, we are just combining like terms. So that means we're taking order of operations. We're dropping the parentheses by distributing some negatives. So I have 3 plus 6i minus 4 plus 8i. We like them to be an A plus BI4. So what that means is that we want the number part to be first. So we're going to combine 3 and negative 4 to get negative 1. They're like terms. They're real numbers. We're going to combine 6i and 8i to get 14i because they're like terms. In 10, get rid of the parentheses by distributing your negative. So you have 8 plus 3i minus 2 minus 4i. So again, combine your like terms. 8 minus 2 is 6. 3i minus 4i is negative I. Seven minus 3 and negative 2. You have to distribute the negative to both. So it's 7 minus 3 minus 2i. 7 and 3 give 4 minus 2i. You can pull a GCF from these. So if it said something like factor or find the GCF, you can still pull away a 2. So you could rewrite it as 2 minus I. You can pull GCFs from these. So all those properties that we've already talked about, everything we already know, doesn't change. Okay? In 12, the parentheses are simply there to mess with you. They don't do anything. There's nothing being distributed. There's nothing being subtracted. They're just there to make you understand order of operations. Once again, combining only the i's with the i's and the reals with the reals. The 4 carries along. Negative 6 plus 3 becomes negative 3. We are going to pause here for the day. I want to pick up with the rest of it tomorrow. You only have 7 problems to do tonight for homework.